Forget the days when farmers used the farmer's almanac to check a forecast to start planting. Science and technology are being used by next-generation farmers to provide a step improvement in yields, growing more from less. Here are 4 of the most fascinating developments to keep an eye on. Number 1. Apple picking robot. With an $80 billion market and a labor-intensive process, apples are one of the fruits most commonly consumed worldwide. Abundant automates apple harvesting in order to assist the farming workforce. Around the world, apples are grown and eaten in a variety of geographic climes. Economic recessions and declining incomes have little effect on the market. It's able to recognize the ripe ones, pick them and store them. A vacuum-controlled mechanism and cutting-edge algorithms are used to make it function. They are made to be powerful and quick enough to remove 1 fruit from a tree per second, while being soft enough not to harm the fruit or the trees. The little tractors that are currently widely utilized in fruit growing are employed to provide power for the robots. Number 2. Harvest Crew. Harvest Crew is a harvesting robot that has cutting-edge components for snagging leaves, collecting strawberries and packing them. It can tell ripe fruits apart from unripe ones. A 360-degree, 3-dimensional image of the fields is provided by the LiDAR system mounted on the harvester. This makes it possible to navigate down strawberry rows with more accuracy. The completely autonomous harvester is able to do this without running into any obstacles like humans or growing rows. As the harvester moves autonomously across acres of strawberries, each one has 16 autonomous robots ready to harvest. Each berry on a plant is examined by the artificial intelligence and machine learning vision system to determine if it is ripe, healthy, and ready to be picked. A berry is then selected by the harvester without causing any harm to the fruit. Number 3. BR2000. The Holoras BR2000 beet cleaner is appropriate for cleaning beets and other types of produce. A broad surface area of the slatted belt combined with the open form of the bucket guarantees an excellent cleaning capacity. A mounting plate and belt along with slats placed around 50mm intervals are included with the cleaner as expected. A bar belt that is operated by hydraulics is housed inside the bucket. The roughness of the bar belting can be modified according to the amount of dirt. For instance, before beets produced on clay soil can be utilized as feed, they must undergo extensive washing. The cleaner may be used for various crops such as potatoes and Jacoby roots due to the adjustable space between the bars. The bucket can be tilted slightly after the beets have been scooped, causing them to roll inside. Number 4. Savannah Stump Puller. Using a stump puller is one of the most efficient ways to deal with remaining stumps in an agricultural or forestry setting. Models 1710 and 1720 of Savannah's leading stump puller attachments were created with this use in mind. The designs, which are patented, include Model 1710, which can draw smaller stumps between 8 and 20 centimeters in diameter, and Model 1720, which can pull bigger stumps between 10 and 58 centimeters in diameter. In order to lift the stump and main root structure sufficiently high to be released from the soil for effective raking, the stump pullers employ lifting wheels positioned at an ideal geometry to grip and lift the object. To do this, a powerful tractor or bulldozer is used to tow the stump pullers. The ideal pulling speed for the Model 1710 and 1720 is 6.4 km an hour and 4.8 to 7.2 km an hour respectively. The Model 1710 can de-stump a given area at a rate of 1.2 to 1.6 hectares per hour, whereas the Model 1720 can generate 1 to 1.6 hectares per hour. The productivity may be impacted by stand characteristics such as typical stump size, stump height and structure of roots, stump weight, row spacing, soil quality, debris on top of stumps, as well as towing machine traction and pace. These technologies have systems that carry out meticulously precise labor or jobs demanding high effort to autonomously operate successfully in difficult agricultural conditions. What do you think about this improvement in the agricultural industry?